Hello friends, this is Nitin Kulkarni. In the last video, we looked at how to set up our Jenkins server, and in this video, we'll be setting up our Ansible controller node and then connect it to a test server. In the last video, we created the Jenkins server. Now let's take the next step and create an Ansible controller node. The easiest way is to select the instance that we previously created, click on Actions, and go to Launch More like this. Click Launch, select the same key pair, launch instances, and now our instance should be coming up. Let's change the name to Ansible controller node. Let's give it a second or two to. Okay, our instance is now running. It has the public IP address and the private IP address. Let's copy the public IP address and connect to it using the MobiX term. So go back to our MobiX term application, and I had previously created the Ansible controller sessions. I'm just going to edit it, provided the new IP address, everything else remains the same. Click OK and double click on it to start the connection process. I'm now logged into the Ansible controller node. Let's create a non-root user first, switch to super user, and then say user add ANS admin. Create a password for this user, ANS admin. Okay, our user is now created, the password is now set. Now let's add this user to the sudoers file. Navigate to the allow root to run any command section and then add our user over there. That's it. Let's save this file, come out. There is one more change that we have to make, and that is to set the password authentication to yes. Let's do that now. vi/etc sshd config. Navigate to the area where it says password authentication no, and change it to yes. Save this file, come out, and now execute this change, which is done like this: systemctl restart sshd. Now this will make our changes effective immediately. Let's try to understand why we have to set the password authentication value to yes. We have our Jenkins server and we are about to install and create an Ansible controller node. And then subsequently, we'll also be creating more virtual machines that will act as our Ansible managed nodes. And at one point in the process, we are going to write Ansible playbooks, and then we are going to instruct our Jenkins job to run the Ansible playbook. But before Jenkins job could make these Ansible playbooks run on the Ansible controller node, we'll have to log into our Ansible server from the Jenkins job. And we are going to use the password-based authentication for our login process, and this is where the password authentication value to yes will come into play, and if the value is set to no, it will not let us log in, and that's the reason why we have to set this value to yes. Now let's switch to this user that we created, so su ANS admin, and then start our installation process. The first command to be run is this, which will download the Ansible package on our machine. Okay, now let's run the Ansible installation command. So type sudo yum install Ansible and provide a -y flag, hit enter, and it should start the installation. Our Ansible is now installed. Now, for those of you who know how Ansible architecture works, uh, should be aware that we will soon be creating our Ansible managed nodes. And we need to inform our Ansible controller node which servers are our managed nodes and what their IP addresses are. So we are going to first create our managed nodes and then inform our Ansible controller node where those nodes are configured. So that way, then Ansible node, Ansible controller server will then be able to configure the Ansible nodes when the time comes. So as we talked about in the bird's eye view picture, we are going to need three Ansible managed nodes. So let's go ahead and create them. So I'm going to use this create launch more like this option from here. And this time I'm going to I'm going to try and launch more than one at a time. Let's see how I can do that. Um, okay, so I'm going to go to configure instance and specify number of instances as three. That way I don't have to create two more instances later. I can create all the three right now. Nothing changes. I'm just going to make sure that the rules allow all traffic from anywhere to communicate. And as we discussed previously, that's not a good option, but that's what we'll do for now because this is just a demo project. So review and launch, and then click launch, select the key pair, and our three instances should now start coming up. I'm going to name them appropriately based on what they're going to do. So let's try to name them. Okay, my three Ansible managed nodes are now running. I have named them as Ansible managed node test server, Ansible managed node prod server, Ansible managed node Selenium grid. Let's now connect to these machines and configure our controller node and include the names of these servers in something called as the host file. I'm back to my controller node and I'm going to edit a file called as etc ansible hosts, and I'm going to scroll right to the bottom and copy. I'm just going to change this to test server and then specify the IP address of my test server, which I will get from my dashboard. So this is my test server right here. Now here I have to use the private IP address or the internal IP address because these are all AWS instances, so they don't need to communicate with each other using external or public IPs. Right, so this is done. Save this file. Um, oh, I made a mistake here, so let's correct that. And the mistake was that I did not edit this file as a sudo. So I'm going to do that now and repeat what I just did. So take everything from here, come here, paste it, change this to test server, and then paste the internal IP address, which is, I'll copy it from here again. Okay, it should save now. Okay, so what I have done is I have told my controller machine where my test server is. And this is a very critical step for Ansible to be able to, Ansible controller node to be able to communicate with the Ansible managed node. So let's now try to see if these nodes can communicate with each other. The command to try the communication is Ansible all -m ping. let's run this command and let's see what happens. Okay, so it says it's unreachable, and it's unreachable because it says the permission is denied. This is most likely the experience that you will also get if you try this command without taking one step which we intentionally missed. So permission denied is what we are going to get. Now let's try to see how we can fix that. Let's understand first why we got the permission denied message and then understand how we can fix it. So far, we have the ANS controller node and the Ansible host machine. Let's see what's going on between them.
I want to talk to you.
I don't know you, you need to authenticate yourself first.
How do I do that?
You can send me the public key of the user you want to authenticate as. Why don't you ask your user Ansadmin to send me his public key?
I am Ansadmin. I am going to log onto the controller machine and create my key pair. After that I will log onto the host machine and send my public key.
ANS admin then logs into the Ansible controller node and using the SSH keygen command generates a pair of public and private key. The public key then would need to be copied into the trusted key store file on the Ansible managed node for the same user.
Yay, we are friends now. You can log on to me without using any password.
Let's try to understand the concept of SSH keys in a bit more detail. And if you're already familiar with this, please feel free to skip this part of the video. But when it comes to SSH keys, there are two major concepts. One is the host key verification, and the second is the key-based authentication. So host key verification is where a client should know that the server that he is trying to connect to is indeed the server it claims to be. So for example, if you're trying to connect to yahoo.com, how do you know that you're actually connecting to yahoo.com and someone else is not impersonating as yahoo.com? So SSH host key verification will make sure of that. And the second is the key-based authentication, where now it's the other way around, where a server must now know who is the user trying to connect and whether or not he or she is allowed to connect to that server or not. So now let's try to dig into the host key verification and key-based authentication in more detail and understand what exactly happens behind the scenes. Let's now look at host key verification. Let's say we have Brad. He's a system admin for foo.com and has just initialized the server. He then creates the key pair for foo.com, and as a part of the key pair, he creates a public key for foo.com and a private key for foo.com. So now Emily, who is our end user, tries to connect to this server using an SSH client. The first thing that the server does is to transmit the public key to Emily's SSH client. The SSH client then checks if the key is present in a location known as the known_hosts file, and if the entry does not exist, it will prompt you to add the key to this particular file. By adding the key to this file, you are now trusting the public key sent to you by the server. What happens next is really very interesting. The SSH client generates a message which is then encrypted using the public key sent by the host. The encrypted message is then transmitted back to the server, and the server then tries to decrypt it with the private key that it already has. If the server is successful in decrypting the message, that means it holds the right private key that matches the given host key. That means it is who it claims to be. Let's now try to understand what is key-based authentication. So we have our server foo.com, and we have Emily who wants to access foo.com without using password. Let's see what Emily does.
Let me create keys for myself on my local machine.
Emily uses the open SSH utility called as SSH keygen to generate her keys.
I need someone to copy my public key in the home folder for me on the server. Let me contact Brad. Can you help me copy my public key on the server?
Sure, just copy the public key and send it to me, or you can send me the public key file.
Brad then logs onto the server and creates a user account for Emily and copies the public key into her home folder. Emily now tries to connect to the server, and as a part of that interaction, presents the user ID and the public key to the server. The server checks if the key is already present, and now it wants to make sure that it was actually Emily who submitted the key and not someone else. It creates a token, and using Emily's public key, encrypts the token and sends it back to Emily, expecting her to decrypt the token using the private key on her side. The decryption was successful. Emily is now granted access and she can perform the operations on the server. So this is where we were before we took a slight diversion to understand what SSH keys meant and how they worked. So we faced this permission denied message, and now that we know how the SSH keys work, we now understand that we have to copy the um, certificates for or the certificate key, the public key for the user ANS admin onto the host machine. So let's first create the keys. We may have created the keys in the previous session, but let's try to create the keys one more time. And as Emily did, we're going to use the SSH keygen command to create our public and private key pair. So I am now already logged in as ANS admin. So I have logged in as CentOS, and then I switched to ANS admin, and now I am the ANS admin user. So I'm going to type SSH keygen. Yes, yes. So I looks like I already had one. Enter empty phrase. I'm not going to put any phrase right now. No, no. So the reason why I did not put a passphrase is because Ansible at the runtime is going to communicate with our host machines, and we do not want it to stop or wait for someone to enter the password. Generally, when it comes to certificates, putting in a password is a good practice, but this probably is going to be one of those exceptions. So now we have our public key present here, which is home nsadmin.ssh id rsa pub, and the private key is present here. Now what I need to do is I need to copy our RSA ID RSA pub key to the host machine. But as we discussed, just like Brad did, we also had to create a user account ANS admin on the corresponding test node server. Okay, so let's do that. So as you can see here, I'm now on test server, and I tried to switch to ANS admin. ANS admin did not it does not exist, so I'm going to do a user add ANS admin. Okay. Okay, sorry, I have to do su. So I have to do it as root. So sudo su, and then I'm going to try this again. User add ANS admin. Okay, user is added. Now let me set the password for ANS admin. Okay, so now my the authentication tokens are now successfully set. My user is created. Now let's try to connect to this machine, or rather copy the certificate from the controller node to the test node. So this is the command to copy the public key from my controller node to the test server. And so basically what I'm doing is I'm telling this current server to copy the public key and put it into the home directory of the ANS admin user, um, or rather the trusted key store file for the ANS admin user on the IP address of the test server. So let's see what the IP address of our test server is. Our test server is right here, this one. I'm going to take the private IP of this server, go to my mobix term, paste it here, and now let's try to do the copy one more time. Okay, so now, okay, here is what it's doing. It's asking me, so there are multiple ways. Before I enter the password here, let me explain that there are a couple of ways of copying the ID onto the test server. One that we saw in the previous video was that Emily gave her key or copied over her key to Brad, and then Brad then created the user account and then copied the key into the home location for Emily. Here, what we're going to do is we are going to log in from our test controller node onto the test server as ANS admin, and then copy our key over there. So this alternative way or another way of copying the public key onto our test server. So let me enter the password that I specified when I created ANS admin on that other machine, the test server. Password entered, and now what it says is number of keys added is 1. It was able to copy the key from the ID RSA pub and copy it onto the trusted keys file onto the test server. Let's make sure that the key was really copied or not. So what I'm going to do is I'm going to uh, print the key here. So let's say I did a cat of the ID RSA public key, and just notice here it starts with 1, 2, 3, 4 A's, and then it ends with the IP address, user ID and the IP address, and GGFBZL. It ends with that. So let's see if this key is present on our test node or not. So what I'm doing is I'm basically going to, I've already switched over to ANS admin. Now I'm going to home, the user ID ANS admin dot ssh, and there must be a file called as trusted keys over here. Sorry, authorized keys over here. So I do a cat on this authorized file, and let's see. So it is A, so 4 A's, and then I have GZFBZL. And so I'm not going to obviously compare every single character here, but it seems like it copied the right key into the right folder. And that is why when I copied the key, it said one key added, right? So our key has been successfully copied, which means now our ping command that previously failed should work now. Let's try that. So I've typed here Ansible all -m ping. So I'm going to press enter and let's see what happens. Okay, so now it is a success. The Ansible controller node was successfully able to connect with the test server here. So when we write our playbooks and execute our playbooks, it is now going to be able to run those playbooks and impact the configuration on our test server. So that's a great thing. We have successfully established communication between the Ansible controller node and one of the Ansible managed nodes. Now let's take the next step. So as a quick recap, here is where we are. We have set up our Eclipse. We have set up our Git account and created a repository over there. We have established the communication between Eclipse and Git. We have set up our AWS environment, not fully yet, but partially. And on the AWS environment, we have created our VM virtual machine, the CentOS VM, where on one of which is used to install Jenkins, and then the other VM we installed the Ansible controller node, and then on the third VM we have installed the Ansible manage node, and we have now established a communication between these two nodes successfully. So the next step now is going to be for us to build and push the Docker image to the hub. So we're going to first understand how to build a Docker image using Jenkins, and then what it means to push a Docker image to hub, and what exactly is a hub, and what do we do there. All right, so that is what we are going to do next. Thanks for watching the video. I hope to see you in the next video and continue this DevOps journey.